Welcome back to the deep dive. Today we're zooming all the way in.
Yeah, going microscopic.
Right, microscopic. But the implications of what we're about to discuss today are they are huge. We're talking about biological shapeshifters.
Shapeshifters is, it's honestly the absolute best way to describe them. It sounds like science fiction, you know?
It really does.
But this is evolutionary biology at its most elegant and, frankly, its most terrifying.
Yeah, because we're looking at a specific group of fungi that don't just infect you. They fundamentally redesign their own architecture the moment they enter your body.
Right.
So today we are diving into Chapter 64 of Murray's Medical Microbiology. That covers the systemic mycoses caused by dimorphic fungi.
And we are going to sprinkle in some crucial details from Javits as well.
Mostly Chapter 45 from Javits, right?
Exactly, Chapter 45, specifically regarding the morphology, just to give you all the complete picture.
Now, before we get into the specific killers, and there are some absolute heavy hitters here like Blastomyces and valley fever, we need to set the stage.
We do.
We need to understand the why. Why does a fungus need to shapeshift at all?
It's a great question. And to understand the why, you have to look at the environment these things come from.
Where they live naturally.
Right. These fungi are soil dwellers. They live in the dirt, in rotting wood, in bird droppings. And in that environment, the temperature is ambient, usually around 25 degrees Celsius.
And at that temperature, they exist as molds.
Right, they're molds. Molds are filamentous. They grow in these long branching structures called hyphae.
Like roots.
Exactly like a root system spreading out to find nutrients. And they produce spores conidia that are light, dry, and designed to catch the wind.
Perfect for the soil.
It is the perfect design for the soil.
But then a human walks by. You kick up some dust,
Mm-hmm.
you inhale those spores, and suddenly the environment changes drastically.
Drastically. The spore lands in a warm, wet, hostile lung. The temperature jumps from 25 to 37 degrees Celsius. That is a massive thermal shock. If you are a common bread mold or a slime mold, that temperature, combined with the immune system, is just a death sentence. Your hyphae are too long, they're too fragile, you just get shredded by phagocytes.
So the dimorphic fungi, they have a backup plan.
They have a transcriptional switch. It's almost like a panic button that rewrites their genetic instructions on the fly.
Wow.
When they sense that heat, they stop making filaments, they pull in their structure, they thicken their cell walls, and they transform into yeasts.
Which brings us to the foundational mnemonic of this entire deep dive. Mold in the cold, yeast in the beast.
Yes, exactly. Mold in the cold, yeast in the beast. In the soil, they are molds designed for dispersal. In the body, they are yeasts, or, well, in one case we'll talk about spherules.
That was the exception.
Yeah, but they are designed for survival. They become these armored tanks that can withstand the heat and resist being eaten by our immune cells.
And this isn't just some defensive move, is it? I mean, this transformation is actually a virulence factor.
Oh, it is the primary virulence factor. Without this ability to transition, they cannot cause disease, period.
Wow.
And that distinguishes them from opportunistic fungi, things like Candida or Aspergillus.
Because those are already hanging around.
Right. Candida is already in your body, just waiting for you to get weak. These dimorphic fungi, they are primary systemic pathogens.
Meaning they can take down a totally healthy person?
Yes. They are entirely capable of infecting immunocompetent hosts.
That's scary.
Now, if you have a healthy immune system, specifically strong T-cell immunity, cell-mediated immunity, you will likely wall off the infection and never even know you had it.
But the potential is always there.
Exactly. They don't need you to be sick to break in. They have the keys to the castle.
Okay, so our mission today is to decode Murray Chapter 64 for you. We are going to build a mental map for everyone listening.
Whether you're a medical student prepping for boards or just someone fascinated by how things kill us.
Right. We're going to break this down into 3 pillars for each organism.
Geography, morphology, and pathology.
Where they live, what they look like, and how they hurt you. If you can master those 3, you own this topic.
And really pay attention to the geography. In medical microbiology, geography is often destiny.
For sure.
A patient with pneumonia in Arizona is a completely different diagnostic puzzle than a patient with pneumonia in Ohio. The map tells you the bug.
All right, let's open the dossier on our first suspect. This one is known as the Great Masquerader. We are talking about Blastomyces.
Blastomyces dermatitidis. And recently, geneticists have actually split it into a second species, Blastomyces gilchristii.
Oh, really?
Yeah, but clinically and for your exams, they are identical. We just call it blasto.
Blasto. Okay, let's start with the map anchor. Where are we standing if we catch this?
We're standing in the eastern half of North America. Visualize the great river systems, the Mississippi River Valley and the Ohio River Valley.
Okay.
But it extends further north than people realize, up into the Great Lakes region, Wisconsin, Minnesota, and east along the St. Lawrence River.
It seems to really hug the water.
It does. Blastomyces is a fungus of damp, rotting woods. It loves decaying organic matter. Think of acidic soil, rotting logs, thick leaf litter.
I read about this outbreak once that was associated with beaver dams.
Oh, that's a classic case study. There was a group of people dismantling a beaver dam, kicking up all that rotting wood and moist soil into the air.
It sounds like a perfect storm.
It was. They inhaled massive amounts of spores. It really reinforces the niche. Wet, decaying wood.
So if you were taking a patient history, you're looking for campers, hunters, forestry workers.
Your weekend warriors clearing brush in the Midwest or Canada.
Okay, let's look at the second pillar, morphology. You've inhaled the spore. It's 37 degrees inside the lung. It transforms.
No.
What are we seeing under the microscope?
This is one of the most high-yield visuals in all of mycology.
It really is.
You are looking for yeast. It's relatively large, about 8 to 15 micron.
Which is roughly the size of a red blood cell, right?
Yeah, or a little bigger. And it has a very thick refractile cell wall. We call it double contoured because under the microscope, the wall looks so thick it creates this distinct double line.
But the signature is the budding.
The budding is the absolute fingerprint. Most yeasts, like Candida, bud with a narrow neck. It looks like a balloon tied off with a string.
Right.
Blastomyces has a broad-based bud.
The triple B.
The triple B. Imagine a snowman. You have the base snowball and the head snowball. In Blastomyces, the head is almost the same size as the base, and the connection between them is wide.
It's not pinched off.
No, it's a thick, sturdy connection.
So if I see a snowman with a thick neck and a thick glowing wall and a tissue sample, that is Blastomyces.
That is diagnostic. You don't even need the culture if you see that clearly in tissue.
Awesome. Now let's talk pathology. Why do they call it the great masquerader?
Because of how it confuses doctors, it mimics cancer perfectly.
Walk us through that scenario. How does that happen?
Okay, let's say you have a 55-year-old man from Wisconsin. He comes in with a lesion on his face, maybe on the side of his nose. It's ugly. It's verrucous, which means wart-like.
Okay.
It's crusty. It has heaped up serpiginous borders, maybe some ulceration right in the center.
Honestly, it looks like a squamous cell carcinoma.
It looks exactly like squamous cell carcinoma. The dermatologist takes a biopsy, and here is where it gets dangerous. The body's reaction to blastomyces in the skin is to produce this massive overgrowth of skin cells.
Pseudoepitheliomatous hyperplasia.
Exactly. And if a pathologist just glances at it quickly, it looks like uncontrolled cancer growth.
So the patient gets referred to oncology.
It happens more often than you'd think. Patients have been prepped for surgery or radiation because everyone is convinced it's cancer.
That's terrifying.
It's only when someone does a special stain, like a GMS silver stain or a PAS stain, and sees that broad-based budding yeast hiding in the tissue that they realize, wait, this isn't cancer. This is a fungus.
That is a huge save.
Yeah.
You go from you have cancer to take this antifungal pill.
It is the definition of a great clinical catch.
Is the skin the only place it goes once it disseminates?
No. Remember, it starts in the lungs. Inhalation. It causes a pulmonary disease that can be anything from an asymptomatic mild cough to full-blown atypical pneumonia with lobar infiltrates.
But if it breaks out?
If it disseminates, skin is the #1 site. The #2 site is bone, osteomyelitis.
And there is one other specific site that always shows up on board exams as a distractor.
The prostate. Blastomyces has this strange affinity for the male genitourinary tract.
Good to know.
So if you have a male patient with pneumonia, a cancer-like skin lesion, and symptoms of prostatitis, that triad screams blastomycosis.
Murray also mentions a cousin to Blastomyces that breaks the rules a little bit.
Yeah.
Blastomyces parvus.
Right. This is a bit of taxonomy trivia, but it's interesting. It used to be called a Monsia, and it's an outlier because it doesn't form yeast.
It doesn't bud at all.
No. In the lungs, the spores just swell up. They get massive, like huge balloons. We call them adiospores. Yeah. They don't replicate. They just get big and clog things up. But for the most part, when you hear blasto, assume we were talking about B. dermatitis and the budding yeast.
Okay, let's wrap blasto with treatment. We've diagnosed the snowman. How do we melt it?
The treatment protocol is fairly standard for all these primary systemic fungi. It depends entirely on severity.
Right.
If the patient is walking and talking mild to moderate disease, we use itraconazole. It's an oral azole, very effective.
And if they are crashing,
Yeah.
if they have CNS involvement or severe respiratory failure.
Then you have to bring out the heavy artillery, amphotericin B, specifically the lipid formulation to save their kidneys.
Right, lipid ampho B.
You use that to bomb the fungus initially, then step down to itraconazole for the long haul.
All right, let's leave the damp woods of Wisconsin. We are getting on a plane and flying southwest. The air is drying out, the soil is turning to sand. We are entering the territory of Coccidioides.
Also known as valley fever.
I like to call this one the desert grenade.
That is a very evocative and highly accurate description.
Let's start with the geography. We are in the desert.
Specifically, the lower Sonoran life zone. This is a bioregion that covers Arizona, Central and Southern California, like the San Joaquin Valley, New Mexico, West Texas, and Northern Mexico.
It's hot, arid, and dusty.
And the life cycle of Coccidioides, whether it's C. amidus in California or C. posidacea elsewhere, they are clinically indistinguishable. It is intimately tied to the weather patterns here.
The bloom and blow cycle.
Exactly. It starts with rain. When it rains in the desert, the fungus blooms in the soil. It grows rapidly as a mold. But then the rain stops, the heat comes, the soil dries out.
When the fungus panics.
Well, the fungal hyphae become incredibly brittle, and they break apart into these tiny barrel-shaped segments called arthroconidia.
They look like boxcars on a train.
Yes. Alternating cells, one full, one empty. These empty ones are called disjunctor cells, and because they are so light and disjointed, the slightest breeze just picks them up.
Or an earthquake. Or a construction crew digging a foundation.
That's exactly why you see huge spikes in cases after dust storms or earthquakes in those regions.
You inhale these arthroconidia, and this is where the grenade metaphor comes in. Because unlike blasto, unlike the others, this fungus does not become a yeast.
It completely breaks the yeast in the beast rhyme.
It does. It forms a structure called a spherule.
Describe the spherule for us.
Imagine that barrel-shaped spore lands in your lung. Instead of budding, it starts to swell, and it keeps swelling. It becomes massive, 20 to 60 microns.
That is enormous in the microbial world.
It is. It's much bigger than your white blood cells.
So the immune system can't swallow it.
Correct.
Yeah.
It's a classic case of frustrated phagocytosis. The immune cells physically cannot eat it. It's just too big. And inside this giant sphere, the fungus is dividing by internal cleavage, creating hundreds, sometimes thousands of tiny endospores.
It's packing itself with shrapnel.
That is the grenade. Eventually, the pressure is just too high, the spheral wall ruptures, boom! It releases those thousands of endospores into the surrounding lung tissue. And every single one of those endospores can grow into a new grenade.
Precisely. That is why Coccidioides is so infectious. In fact, it's considered a potential bioterrorism agent. If you work in a lab and you open a petri dish with Coccidioides mold, you are in serious, serious danger.
It's highly biohazardous.
Only a few arthroconidia are needed to start an infection.
So, clinical presentation.
Mm-hmm.
Most people who live in Phoenix probably breathe this in eventually. Do they all get sick?
No. About 60% are completely asymptomatic. The other 40% get valley fever. It feels like a bad flu. Fever, cough, chest pain, fatigue that can just drag on for weeks.
But there's a very specific skin reaction associated with this that students absolutely need to know. The desert bumps.
Erythema nodosum. This is a massive clinical pearl. These are painful, red, tender nodules that usually appear on the shins. It looks like you got kicked in the shins repeatedly.
Yeah.
You might also see erythema multiforme.
And paradoxically, having these painful bumps is it's good news.
Yeah. It is the best news. Erythema nodosum is an immune complex hypersensitivity reaction. It means your immune system, specifically your cell-mediated immunity, is reacting vigorously to the fungus.
Okay.
It suggests you are mounting a very strong defense, and you will likely clear the infection on your own.
So painful shins equals strong immunity equals good prognosis.
Exactly. If you have a patient with confirmed valley fever but no skin reaction and their antibody titers are climbing, that's scary. That means the immune system isn't containing it.
Let's talk about those who don't contain it. Dissemination.
If it breaks out of the lungs, it goes to the skin, causing ulcers. It goes to the bones and joints. They actually call that desert rheumatism. But the one that really kills you is meningitis.
Fungal meningitis.
It is a devastating complication. If untreated, it is fatal. Even with treatment, it usually requires lifelong antifungal therapy. The fungus literally invades the membranes around the brain.
Now, you mentioned earlier that geography is destiny, but with cocci, genetics seems to play a huge role too.
This is fascinating and really tragic. We have solid epidemiological data showing that certain ethnic groups, specifically Filipino, African American, and Native American populations, have a much higher risk of disseminated disease.
They're far more likely to get meningitis than the general population. Do we know why? Is it socioeconomic?
It appears to be truly genetic susceptibility. The leading theory involves HLA types, the genetic markers your immune system uses to recognize threats. It seems certain HLA types common in these populations are just not good at seeing or presenting the Coccidioides antigen to the T cells.
So the immune response is weak from the start.
Exactly, and the grenade just explodes unchecked.
There is one other high-risk group that defies the usual immunosuppressed label: pregnant women.
Yes, specifically in the third trimester. This is a classic board exam question.
Why does pregnancy make it worse? You'd think it's just because the immune system is dampened during pregnancy.
You might think that, but it's much more specific. It turns out Coccidioides actually has receptors for human hormones.
Wait, the fungus has receptors for our hormones.
Yes, it has receptors for estrogen and progesterone. In the third trimester, those hormone levels are skyrocketing in the mother. The fungus effectively intercepts those hormones and uses them as a growth factor.
That is incredible.
It actively stimulates the release of endospores.
The pregnancy hormones literally fuel the fungus.
It's like throwing gasoline on the fire. So if you see a pregnant woman in Arizona with a cough, you have to be incredibly vigilant.
What about diagnosis?
Serology is king here. We look for IgM, which is early, and IgG, which persists. If the IgG stays high, that's a bad prognosis.
And the titers?
If the complement fixation, the CF titer, is high, usually defined as greater than 1 to 32, that strongly suggests dissemination. It correlates directly with the fungal load. And of course, finding the spherule in tissue is diagnostic.
And treatment?
Fluconazole. This is a shift from Blasto. For Cocci, especially meningitis, we love fluconazole because it has excellent penetration into the central nervous system. It gets right into the brain.
And for pregnant patients?
You have to be careful with azoles in the first trimester, so amphotericin B might be used then, or for severe respiratory cases.
Okay, we've done the snowman in the woods and the grenade in the desert. Let's head back to the river valleys, but we are changing the niche. We are looking for the intracellular hider.
Histoplasmosis. Histoplasma capsulatum.
Geography first. We are back in the Ohio and Mississippi River valleys. The map overlaps perfectly with Blasto, so how do we tell them apart?
By the specific location details, Blastomyces is rotting wood and water. Histoplasma is all about nitrogen, high nitrogen soil.
And where do we find high nitrogen in nature?
Bird and bat droppings, guano.
So the classic patient isn't dismantling a beaver dam. What are they doing?
They are spelunking, exploring caves, and inhaling pat guano dust.
Right.
Or they are cleaning out an old chicken coop.
Right.
Or they are tearing down an old building where starlings have been roosting for decades.
The spelunker from Ohio, that is the archetype.
Exactly.
Let's look at the morphology. What does the mold look like in the soil?
The mold has a very distinctive spore called the tuberculate macroconidium.
That sounds like a spell from Harry Potter. Tuberculate macroconidium.
It's a great visual, though. Imagine a large, round spore covered in these knobby spikes. It looks like a medieval mace or an old naval mine.
The spiky ball. Got it.
But that's the mold. You inhale it. It warms up to 37 degrees, and it transforms into the yeast. And this yeast is the polar opposite of the Coccidioides grenade. It is tiny.
How tiny are we talking?
2 to 4 microns. That is significantly smaller than a red blood cell. It is small enough to be easily eaten by macrophages.
And that is exactly what it wants.
It is. This is the ultimate Trojan horse strategy, the host-pathogen chess match. The macrophage eats the yeast, expecting to kill it. Normally, the macrophage would fuse the yeast with a lysosome, a bag of acid and enzymes, and digest it.
But histoplasma cheats.
It modulates the pH inside the compartment. It neutralizes the acid and survives the lysosomal fusion.
So it turns the stomach of the macrophage into a cozy living room.
Precisely. It replicates inside the macrophage. And since macrophages are mobile, they are the beat cops of the immune system, they travel.
Right, they circulate.
They go to the lymph nodes, the liver, the spleen, the bone marrow.
And they take the fungus right along with them.
That is exactly how it disseminates. It targets the reticuloendothelial system, the RES.
So when we look at pathology, that completely explains the symptoms. Why do patients get hepatosplenomegaly, the enlarged liver and spleen?
Because those organs are literally packed with infected macrophages.
Why do they get pancytopenia, low blood counts?
Because the bone marrow is overrun.
And if we look at a biopsy, say a bone marrow smear or a blood smear, What is the visual anchor for the exam?
You are looking for a macrophage, a big immune cell that is absolutely stuffed with tiny dots. Those dots are the intracellular yeasts. It looks like a bag of marbles.
A bag of marbles.
Yeah.
That's the image. Now, most people clear this, right?
Yes, 90% are asymptomatic or just have a self-limited flu-like illness. But here's a very cool long-term effect. The body fights it off by forming granulomatous little walls of tissue around the fungus. Over time, these granulomas calcify.
They turn to stone.
Yes, so years later you get a chest x-ray and you see these coin lesions or buckshot calcifications in the lungs and spleen. It can look terrifyingly like metastatic lung cancer or TB.
But it's just a scar.
It's just the tombstone of an old histo infection.
Now, what about the disseminated cases?
That's the crash. We see this mostly in AIDS patients with very low CD4 counts. They get the huge liver and spleen, the pancytopenia, and sometimes severe mucocutaneous ulcers. There's also a rare complication called mediastinal fibrosis, where excessive scarring chokes off the great vessels in the chest.
Diagnosis. We have the biopsy with a bag of marbles. What else?
The urine or serum antigen test. This is the gold standard for disseminated disease.
Yeah.
It has very high sensitivity. The fungus sheds parts of its cell wall into the blood. The kidneys filter it out, and we can detect it right in the urine.
And there's a variant in Africa we should probably mention briefly.
Histoplasma capsulatum variety du Boissy. If you have a patient from Central or West Africa, keep this in mind. The yeast cells are much larger, 8 to 15 microns, and it tends to cause more lesions in the skin and bones rather than the lungs.
Okay. We've done the big three of North America. Now we need to get our passports stamped. We are heading south. Way south.
Down to Latin America, Brazil, Colombia, Venezuela.
We are talking about Paracoccidioides mycosis.
Try saying that 5 times fast. Paracoccidioides, brasiliensis, and Pulmonary as well.
I just call this one the pilot's wheel.
That is the classic morphological description. It's sometimes called South American Blastomyces too.
Let's start with geography and niche.
It's the humid tropical and subtropical forests of South America. Brazil is the absolute epicenter. It's often linked to agriculture, specifically rural coffee growers.
So a rural agricultural worker in Brazil presenting with lung issues.
Right. It causes a chronic progressive pulmonary disease, but it has a really nasty habit of eating away at the mucous membranes.
The mouth and nose.
Yes. It causes these incredibly painful, destructive ulcers in the gums, the tongue, the palate, and the nose. They're called mulberry mucosal lesions.
Mulberry.
Yeah. They bleed, they hurt, and they can be severely disfiguring. You also see significant cervical lymphadenopathy in younger patients.
That sounds horrific. Let's look at the yeast form. It's honestly my favorite visual of the bunch.
It is undeniably cool under the microscope. Paracoccidioides yeast is large, up to 30 microns, and it buds in a very specific way. It produces multiple buds simultaneously from a single mother cell.
So you have one big circle in the middle and lots of little circles popping off the rim.
Exactly. They're attached by narrow necks. It looks just like a ship's steering wheel, the pilot's wheel, or mariner's wheel, or if you prefer cartoons, it looks like Mickey Mouse ears on steroids.
If you see that wheel, it is 100% paracocci.
Right.
Now, I want to ask you about the mechanism here. We talked about estrogen with coccidioides, how it acts like gasoline. Paracoccidioides has an estrogen story too, doesn't it?
It does, but it is the exact opposite story. This is one of those binary oppositions that examiners just love to test.
Explain that.
Paracoccidioides is incredibly rare in women. The ratio of infected men to women is something crazy, like 9 to 1, sometimes up to 15 to 1. But exposure is the exact same. Women work in the coffee fields too.
So why don't they get sick?
Because estrogen actually inhibits the transition of paracoccidioides.
It blocks the shapeshift.
Exactly. When a woman inhales the mold, her baseline estrogen levels prevent the mold from turning into the yeast form. And since the mold can't survive at 37 degrees in the body, the immune system clears it easily.
Wow.
In men, there is no estrogen block, so the mold becomes yeast and the infection takes hold.
That is so fascinating. Estrogen helps coccidioides grow, but it stops Paracoccidioides dead in its tracks.
A crucial distinction to keep straight.
And treatment for this one?
Itraconazole is the standard. But interestingly, this is one of the very few fungal infections that actually responds well to sulfonamides, like trimethoprim sulfamethoxazole. It's a unique feature, though itraconazole is usually preferred today.
We have covered the 4 giants.
Yeah.
But Murray's Chapter 64 includes a section on opportunistic emergers. These are fungi that are dimorphic, but are emerging largely due to the HIV pandemic.
Right. The landscape of infectious disease changes as the host population's immunity changes.
Let's talk about Mycoses. This used to be called penicilliosis, right?
Yes. The organism is Mycoses mornefa. This is a major pathogen in Southeast Asia, Thailand, Vietnam, southern China.
Okay.
If you have an HIV-positive patient who traveled to Bangkok and comes back with fever and skin lesions, this absolutely must be on your differential as an indicator disease.
And the animal reservoir is... It's unexpected.
Bamboo rats.
Bamboo rats.
I know. It sounds like a joke, but it's real. The fungus lives in the soil associated with bamboo rat burrows.
Morphology. How do we spot it?
In the lab, the mold form produces a highly soluble red pigment. It literally diffuses and turns the agar red. That's a huge clue. In the tissue, the yeast form is intracellular, so it looks a lot like histoplasma.
It hides in macrophages.
Exactly. But there is a key difference.
The division line.
Right. Saccharomyces is a fission yeast. It doesn't bud like a balloon popping off. It divides by splitting down the middle. So under the microscope, you see a central septum, a line, dividing the cell cleanly in half.
So if we see Southeast Asia plus red pigment plus splitting down the middle, that equals Saccharomyces.
You got it. The clinical presentation is often molluscum-like papules on the face, fever, and hepatosplenomegaly.
And the other emerger is Emergomyces.
This is a newer classification. It used to be part of the Amansia family. It's appearing frequently in South Africa, again, driven by high HIV prevalence.
What does it do?
It causes disseminated infection with terrible skin lesions, very high mortality in AIDS patients. Morphologically, they are small yeast-like cells, but unlike the old Amansia, E. africanus doesn't form spores. It's a reminder that we are still discovering new shapeshifters all the time.
We have covered a massive amount of ground today. We've been to the beaver dams of Wisconsin, the dust storms of Arizona, the caves of the Ohio Valley, the coffee fields of Brazil, and the bamboo forests of Thailand.
We need to bring this all together for the listeners.
Let's do a synthesis. So I want to organize these by size. This really helps when you are looking at that tricky biopsy picture on an exam.
Good idea. Let's go small to large. Number 1, the smallest. Histoplasma, 2 to 4 microns. Fits easily inside a macrophage cell.
Okay, small. Next.
Number 2, small to medium. Saccharomyces, similar size to histo, but remember to look for that central line, the fission septum.
Got it. Number 3.
Number 3, medium. Blastomyces, 8 to 15 microns, about the size of a red blood cell. Look for the broad-based bud.
The snowman.
Right. Number 4, large. Paracoccidioides. Variable size, but can be up to 30 microns. Look for the pilot wheel with multiple buds.
And the biggest?
Number 5, the giant. Coccidioides spherule. 20 to 60 microns, much bigger than a white blood cell. It doesn't bud. It's packed with endospores.
That hierarchy is super helpful. Now, let's do a quick geographical triage. If I say the location, you give me the bug.
Ready?
Mississippi River Valley.
Could be blasto or histo. You have to look at the niche. Wooden skin lesions, blasto, caves and guano,
Histo.
Phoenix, Arizona,
Coccidioides,
Brazil,
Paracoccidioides,
Bangkok, Thailand.
Saccharomyces.
It really is that consistent.
For exam purposes, yes, it's a solid anchor.
Yeah.
In real life, obviously people travel, so always ask for a thorough travel history.
That brings us to the deep dive twiz. We are going to test your recall. I'll give you a scenario. I'll pause for just a second so you can lock in your answer. Then our expert will break it down.
Let's see this stuff. Question 1. You have a 45-year-old construction worker from Ohio. He presents with fever, cough, and weight loss. A chest x-ray shows granulomas. You do a lung biopsy, and you see macrophages that are absolutely packed with tiny oval yeast cells. What is the pathogen? Take a second.
Okay, so the answer here is histoplasmosis. Why? Well, the geography Ohio puts you in the river valley. But the real why is the morphology. Macrophages stuffed with tiny yeasts. That is the Trojan horse. That is histo.
Question 2. A 28-year-old woman is in her 3rd trimester of pregnancy. She lives in Tucson, Arizona. She comes to the ER with a severe cough, fever, and painful red nodules on her shins. What is the diagnosis?
The answer is Coccidioides or valley fever. Why? Tucson is the endemic zone. The painful red nodules are erythema nodosum, the desert bumps. And remember, pregnancy is a massive risk factor because the fungus uses her estrogen to grow.
Question 3. A patient presents with a crusty verrucous ulcer on his nose. It was initially misdiagnosed as squamous cell carcinoma. A deeper tissue biopsy reveals large, thick-walled yeasts with a broad-based bud. He mentions he goes fishing in Wisconsin every summer.
The answer to this one is Blastomyces. Why? Wisconsin is a major hotspot. The skin lesion mimicking cancer is the classic masquerader sign. And the broad-based bud is the definitive morphological anchor, the snowman.
Question 4. A 50-year-old male coffee farmer from Colombia presents with painful, destructive ulcers in his mouth and swollen lymph nodes in his neck. A biopsy shows a large yeast cell with multiple buds surrounding a central cell, looking like a wheel.
The answer is Paracoccidioides mycosis. Why? South American geography. The mulberry mucosal ulcers in the mouth. And that pilot's wheel morphology is completely unforgettable.
Last one, question 5. An HIV-positive patient returns from a trip to Southeast Asia with fever, weight loss, and skin papules. A blood culture grows a fungus that produces a red pigment at room temperature. Under the microscope, the yeast divides by fission with a central line.
The answer is Mycoses, caused by Mycoses marnefe. Why? Southeast Asia plus HIV is the exact demographic. The red soluble pigment is the lab clue, and the fission use, that central septum, is the microscopic clue.
How'd you do? If you missed any, just visualize that map again. Anchor the bug to the place.
And if you really want to solidify this, open your Murray textbook to chapter 64. Look closely at figure 64.1. It shows the drawings of the saprobic mold phase and the parasitic yeast phase side by side. You need to burn those images into your retina. Also, check Table 64.1 for characteristics and Table 64.2 for the summary of diagnostic tests.
We are nearing the end of our deep dive. We've covered the shapeshifting, the maps, the chemical warfare inside macrophages, and the hormonal hijackings. But before we sign off, there is one final concept we need to leave you with.
It's the concept of latency.
Latency. What do you mean by that in this context?
Well, we tend to think of infection as a simple transaction. You catch it, you get sick, you get better. But these fungi, especially Histoplasma and Coccidioides, they can play the long game.
The long game.
Yeah, your immune system might wall them off in a granuloma. You feel completely fine. You move away from Ohio or Arizona. You live your life for 20, 30 years. Then maybe you develop rheumatoid arthritis and get put on a TNF inhibitor. Or you get chemotherapy.
And the walls come down.
The walls come down. The fungus, which has just been sleeping in your granulomas for decades, wakes up. It reactivates. We regularly see patients in London or New York who haven't stepped foot in an endemic area for 40 years, presenting with fully disseminated histoplasmosis.
That is a chilling thought. You carry your geography with you.
You really do. The ghosts of geography past can haunt you. So respect the soil, respect the travel history,
Yeah.
and respect the shapeshifters.
Thanks for diving in with us. We'll catch you on the next deep dive.
Stay curious.